Right, well, here's a change. We've got a Uniden Uniace 100, so 1981 set, and it's come with its original mic. It's also come with a note to say that the radio has been 80 channeled, which means that's illegal, it needs to come out. And normally we do that first, but I'll tell you what, I want to run through this set. I think he says it's only working on one channel, which is typical of some illegal modifications aside. It's the killer of these radios. I don't know quite what the point was, because by the time the CPT channels came out, radios were readily available and from 50 odd quid. So surely this modification must have cost 30 something quid. So why not have the proper radio, because it compromises performance and it eventually kills the radio. So there we are. Don't even go there. It's also got a Roger K-tone. It's got a switch on the back. Perhaps that switches it on and off. And it's also got a noise squelch. Now that can stay as long as it works. K-tone's a grey area that's coming out. Of course, we may not be able to repair it. So we'll power it up. It comes on channel 17, and for some bizarre reason, it's got an LED rather than a lamp. So that can stay, it's not my problem. So I'll put it on channel 20 and we'll connect up the test gear and we'll find a channel which it actually works on. Oh, I've just realised that switch is probably switching between UK 40 and CPT. I'm going to check it. We'll tell you what, we'll start by checking it on PA. And we'll plug the instrument speaker into the extension speaker socket, just like that. Switch to PA, it's already in PA. Radio doesn't work in PA, so that must be what they've done, that must be what they've reused, which is sad because it's a lot of extra wiring. So it is transmitting on 27.93255. What on earth's that? The trouble is you can't alter the frequency on these sets anyway. I really don't know what it's transmitting on. Let's just turn that switch at the back. No, that doesn't alter it, so that must be the K-tone. At least low power's doing low power, so that's not being rewired. So 27.935. Let's put it on channel 1. So it's either 26.965 or 27.60125. It should be. Let's put picture in picture and then you can see what we're doing while I try and waste time exploring what's going on. So 27.946, 27.946, try it to channel 40, 27.934, 27.934. Well, what we're going to do, because I want to performance test this, we'll presume that's supposed to be 27.935, which it is, yeah. So it's 27.935, which is somewhere between the channels. I'm going to set my signal generator for the same frequency so we can hear it work. So we've got no receive. We have got transmit. $27.93, yeah. Let's just try 936 now. Shouldn't make any difference. I think the VCO is running free. No. Right, we'll go to channel 20. I'll put 2779125 as it should be, just in case the transmitter is doing something different to the receive. So there we go, channel 20, radio on channel 20. No receive. Back to transmit. 27, so it's doing 4.6 watts. On low power, it's doing 750 milliwatts. And on high power, it's drawing 960 milliamps. Deviation, probably won't be able to read it. 1, 2. I'm not going to reset the test gear just for that. So, did I say 4.6 watts? That's what I wrote down. 3.6 watts. And when we key it up, it moves across where you'd expect it to. So, I thought I'd start this. I've got 15 minutes, and I think 10 minutes of those have expired. But I thought we'd make a start on it. I've actually been looking forward to this because it's going to be quite a challenge to get it to work. It certainly doesn't work now. The person it originally belonged to has sadly passed away. And I know the person it's been passed on to, who's asked me to sort this out, will be asking the original owner's widow to look at this video. It'd be nice to see the radio back working. But here we are. It's in nice condition other than being so messed with. Screw at the back, hasn't it? That's a soldering iron on the floor. So we'll start by removing the illegal channel modification. I'm worried about the other things as we progress into the video. Great. And let's hope the synthesizer chip isn't missing, because some of these naughty mods remove the synthesizer chip, which is now unobtainable. Otherwise this video will end quite abruptly, won't it? So they've done the piggyback thing. So let's just hope it hasn't killed the phase lock loop. I'm going to turn the power supply off. We also need to change the two 470 capacitors and the two 220 capacitors. I don't think they've failed at this point, otherwise the set wouldn't have lit up. Seeing if we've got the ceramic filter still, or whether they've done the crystal filter modification as well. Right, I'll get this out and then we'll restart the video. Right, some time later, what I've been able to do is sort out links and things underneath between photographs and things sent in by friends, plus the circuit diagram. So we've got cut on the printed circuit there, a link going from there to over there, which shouldn't be there, and then I've had to put a link in here. The good news is it's certainly working on channel 20, as you can hear on receive. So I've not altered anything else, so I still want to do a performance test to see how good or bad it is. I've changed the 4 capacitors, 1, 2, 3 and 4, which are vital that you change. None of them were short circuits. Some of the values were different, but the thing is, if I sent it back, it'd be in next week for one of the capacitor stuff. So for what's the total cost of those? 150, something like that. It's really insignificant. So we're going to see if we can set the VCO, and to do that we want our multimeter. Let's see whether we can get that in shot. What are we showing on there? We're showing frequency, aren't we? But at the moment we are looking for the VCO voltage, which on channel 40 should be 3.5 volts at test point 1. Test point 1 is that resistor, and so in transmit we should have 3.5 volts, which we have. I've just twiddled it till it worked, so I wasn't far out. In fact, I was really spot on, wasn't I? I'm going to see where we are on channel 1. Got 2.2 and the radio is transmitting. And I've got 3.5 on channel 40 and the radio is transmitting. It's doing its stupid Rogers K-tone. That'll be gone in a not too distant future. So that's the VCO set. What they do also is to have you set L18 here for the best oscilloscope reading on test point 3. We usually skip that step if it's receiving, because, go back to channel 20, we're going to tune that as part of the rest of the alignment, so it's going to get covered. But if you got no receive, then that would be a correct thing to do. This is extracted from the realistic 2001 service manual. This is the correct Uniden circuit. So let's see, put that to kind of one side. There's a lot of things to restore, like public address and that, but at least we've made a start. And the set's basically working. So we had, it's off when it was off frequency and just a free running oscillator, because the you know, I didn't measure any of these until I changed the capacitors, so I don't know what's happened, but at least that IC hasn't been killed. It's quite possible the other one was dead, this one, and it must be frightfully clever of people who rub the numbers off. I mean, we all know what what the Europe one is anyway. So, without any further ado, let's just go through the transmitter. Have I got the alignment data? Yes. I've also got a photo, I think Quotage just sent that in, of the switch when we rewire that back to normal. I don't know, it depends how well that squelch works as to whether it stays or not. So we're going to transmit, and it's doing 4.5 watts. It's doing 3.5 watts. So we had 3.6 before, so that was when it was free running. I'll just turn my monitor receiver off. Channel 40. Let's go over to the main meter on here as well. Channel 40, we have got, oh, this is low, 1.6 watts. Remember, I've not altered anything. 1.6 watts. Sorry, that's channel 40. And channel 1, we've got 4.2 watts. So you can see what they've done to try and get CPT channels to do something. They've got channel 1 as the centre point, because they were going lower, weren't they, 40 channels plus a gap. So you've lost it by the time you've got to channel 40, you're only at 1.6 watt, despite it being over the limit at channel 1. So if we were testing this on channel 31, just for the sake of argument, which we would be doing, how many watts would we be doing? And the answer is actually 2.7. So you can see what I'm on about the compromise. Now, we may get a deviation reading, and it says it's 4.2, and I believe the test instrument at the moment, that's the deviation meter, isn't always right on this because it needs the capacitors changing it. 4.2. So that is correct at 3.5 volts. Oh, it's 3.5 volts now. It was out of lock, out of OOL, out of lock. Frequency is not adjustable on these radios, so let's go back to that. Is that switch going to get rid of that silly bleed? Yeah. Where were we? Going on to deviation meter. Oh, we're on that. Frequency meter I was looking for. 2779123 is absolutely spot on. For a 40-year-old set, crystal's absolutely fine. I mean, that is great. But with them not being adjustable, you're totally at however that crystal feels. So let's look at receive, and let's see what we've got. So make sure we've got 2779125 on the signal generator, and let's listen to the receiver. Well, look, it is on the DVA on the cyanide meter. So for 12 dB, we've got 0.67. For 10 dB, we've got 0.52. These are never as sensitive as Cybernet sets. which is probably why they're better for bleed over. And one, that's 20 dB, it's 1 point, we'll be generous to say 1.7. We're not going to test squelch, are we? Full squelch, never opens, and minimum squelch, is unacceptably bad at 2.4. Now I don't know whether that's going to be adjustable, because if it isn't, that isn't good enough and that board's got to come out. So at the moment we've got a K-tone and a noise squelch. Right, so not so bothered what the meters read at this stage, but just for the record, on channel 20 it's reading, it should be the centre of the red zone, so it is, I'll put low. For S9 on receive we should have, and we have, it's absolutely spot on. Meter lamp, LED, switches, pots, sockets, all this has got to be sorted out. So what we'll do before I go and take a break is transmit. So we're on channel 20. I normally have it the other way on, but the way I'm connected, I'll tell you what, let's try and get it the right way on, otherwise it's going to be confusing. So we need to optimise all this. That is peak, and we're at 3.6 watts on channel 20. That has a broken core, but is adjusting fine. We're now over the 4 watts. Can't remember whether this is receive or transmit, and I can't be bothered to look it up. Transmit, and at 4.5 watts. 4.5 watts. Is that supposed to have a core in it or not? I don't know. So we'll have to just look at the notes. L12. It's supposed to have a core. Right. Because what's going to happen is without the core we're going to end up with spurious emissions. So I'm hoping we've got a scrap set. This isn't a scrap set, but we can see it's got the coil there. This is our test bed set, which we have a socket in and a working TC9119, so we can always test the IC rather than having a big cry. It does have issues on that set, but it works enough for me to use as a test bed. What have we got which will give us a core? That might be the right size. It was once a UK 4000, and you know, like the LCL communicator. I like these, but this one's, we bought it like this. It might just give us our missing core. There we go. So we want peak, and we now have peak at 4.6 watts, and then we have to adjust the power with that one, if I remember correctly. With L10. So whichever L10 is, that is L10. Let's make sure it's going to move. So we're going to turn that downwards for 4 watts. Just like that. Now we want to check it on channel 1 and channel 40 to make sure it's within 0.1. We've got 3.95 on channel 40, and we've got 4.03 on channel 1. So that's probably about as balanced as we're going to get. So looking at our paper, that gives us 4 watts. I've already forgotten where I was. Channel 40, 3.95, and channel 1, 4.03. So there we go. Now that should have increased the current consumption. 929, which is actually less, but then it's not making that other chip draw current, and we've tuned it properly. So low power, let's go over to low power and see what we've got, and we've got 360, actually moving around, so it's VR4. Hiding it under there. That one's cleaning. Unlike the last set, this one isn't nicotined up. Actually 420 milliwatt. It's where it seems to want to be. Deviation we'll come back to on the other test set. See whether we can get something out of this receiver. So the detector is where? L19. L19 is that one. So it was 100 microvolts on the signal generator on channel 20. Why am I not hearing anything? Because I've knocked the frequency on the signal generator. So, let's look at the oscilloscope. I honestly thought this was one we're going to have to send back, not done. But there you are, it just goes to show. Well, that was spot on without any intervention from me. We'll have to check these things. So it's 654321. So 654321. 2, 1. I do it the other way around, from the front end towards the IF. Let's go over to the cyanide meter and see whether we can get a bit better receive out of this set, which is working adequately but not exactly shining out. Switch the oscilloscope off, switch the signal generator to 1 microvolt, and then we're going to attenuate it till we get 4 dB on the cyanide meter. So at the moment the signal you're listening to is 0.36 of a microvolt. So as we improve the sensitivity, we then back off the signal generator so the receiver is never saturated. So you can see we've gained a bit there. Now back it off to 4 dB. The signal generator is now at 0.3 of a microvolt. Once again we've got an improvement. We can back that off. Now 0.25 of a microvolt. So all the what sensitivity you've lost by trying to get 80 channels, that is fine. No adjustment needed. That is fine, no adjustment needed. Probably need a bigger signal for these. That hadn't been fiddled with. And that hadn't been fiddled with. So, at least the person doing this had only messed with the front end ones and not the IF. So now let's see what we've got for sensitivity. So for 12 dB, we now have 0.6 of a microvolt. For 10 dB, we now have 0.5 of a microvolt. And if the radio will do 20, it is what? It's still 1.7 microvolts. Squelch. Let's see whether we can fix that or whether that board's got to come out. VR2 by the looks of it, which is our preset there. So squelch to full, 100 microvolts on the signal generator, and this time we'll show the attenuator. Let's hope we can get the squelch to come in. We can't. So, what use is that, folks? I've put the signal generator to full. I don't know whether this is adjustable. I'll turn the set off, cut the sleeving off this. This just would not be working round scratchy corner. I said this could stay if it worked, and so far it doesn't look like it's working properly. So there's no adjustment on that. If that's the, is that the K-tone? You know, I don't know. Well, in fact, it says KGA on it, tells me it's probably the K-tone. So is it this thing? There's a preset in there. Switch the power back on. Well, we can't set it with the preset provided in there, so the K-tone and the noise squelch are coming out. The K-tone was coming out anyway. What we also got to do is to put this front panel back to standard so that the public address wiring all works. So we'll do both of these. I'll do it behind the scenes. Apart from a bit of removal at this point. Don't know where that yellow wire goes, we'll cut that one. Cut that one. That one goes to the on and off switch. And where's that go? Goodness knows. So if somebody can tell me why a noise squelch would, what the point of a noise squelch is, which when the squelch is set to full never opens regardless of any signal, it would be an interesting discussion. At least the set's basically working now. It'll probably take as long to sort this out as the rest of the job has. Good. So that would be alright if it worked, but it doesn't. The other thing we can now look at together is this wiring. So it follows the resistor colour code. So that wire shouldn't be there. We should have a white wire there, which is probably that one which has been chopped off. That's not going to be hard, is it? What else has happened? We've got a thin red wire which shouldn't be there. Black wire's missing. That shouldn't be there. They've just used that as a solder tag. So we should have blank, 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 because you haven't got a third switch on this set. And then we should have yellow, orange, and then we should have white and then red. So it follows the resistor colour code from here. Brown, oh, not quite. Brown would be 1, red is 2. No, I'm telling you fibs. Doesn't. So that red one's in the wrong place. So where's our white one? Let's have a look. Yellow, orange. That black one's nothing to do with what we're looking at. And then we should have a white wire. And I think that white wire, which is lying dormant, is the white wire we want over there. So let's try and thread it through, because otherwise it's going to be marginally too short. Anyway, you don't have to watch me threading wires through. So pause the video. Okay, considerable period later, we've now got the squelch working. So it's rewired back to where it should be. So what we're going to do is, we want the squelch to open for 100 microvolts. There's 100 microvolts. Yeah. That's where the squelch is. So it's opening for 300 microvolts, but I want it to be 100. Oh, there we go. So that's now 100 microvolts. Yep. And now the minimum is 0.75. So there's 1.75. So that is what we wanted. We've got this deviation to do. I'll do it into this test set, and then we'll verify it on the other one. Let's go back to the main meter on this. Wallow, miles out. Just remind myself which one that is. It's that one down there, isn't it? Wow, it's a bit dirty. Wiggle that around a bit. Right, we'll verify that with the test set behind me. So this test set isn't always spot on deviation, with capacitor issues in its deviation meter. Wow, it's spot on. The deviation meter isn't playing up today. I like to double check and triple check things. Right, that leaves us with RF meter and signal meter. Now it was right when it was doing lower power, so going to transmit. So now it's doing a full 4 watts. That's no longer right. So that now is right. Now the S meter needs to be 9. And that's now altered very slightly because that was spot on, wasn't it? That's deviation, that's signal meter. So with the retune it did alter itself. So we're absolutely spot on that. And the other thing I've done is PA. I'll just show you that. Switch to PA. Take it 1, 2. Whoa! Turn the volume down as well. Take it 1, 2. Oh, you can't turn the volume down on these sets. Yeah, right. Well, there's your half-hearted PA. It does work. I think we'll put a tie wrap round there where they've taken it off. But we're now left with a beautifully working set. Obviously I've rewired that switch bank. It's probably taken 3 hours. And the only parts it's had to have are 4 capacitors. So I'm so pleased that that chip wasn't destroyed because unobtainable. Firm in where was it? Brazil has offered me them. They've offered me them for £29 each, but I've got to buy 100. And you know what? Nobody's got the number of people would actually pay 29 quid each, but that's by the time they get to me. Even if I put nothing on them, the people who would actually say, yeah, £29 for one of those chips, no problem, here's your money, I wouldn't sell them. So it's not going to happen. So sets which now have those destroyed. We've now run out of scrap sets. I mean, sets, I'd bought this realistic in at some point. I bought it like this. What a waste of a good set. And of course we've had the chip out of that. And that's been the way we've been able to get them so far. Right, so just to finish off, see if there's anything there shouldn't be. Hiccups there. Graham, I asked 2 people if they got a Uniden 100 kicking around, so as we're getting one out of storage. And Graham got back to me, and thank you very much, Graham. So we've got that, and can compare. I'll just turn it off. Yeah, I've got another set with a blob just there, and I haven't got a blob there, but it doesn't actually go to anything. So we haven't got that decoupling capacitor, but I've got that one. I've got that decoupling capacitor. So if there's any other malfunctions, I can look back at that now, and I've got that on file. Good. Well done, Graham. Right, well, let's see if we can put the lids on and the set still work. So I had no intention when we started this and when I quoted for this to take the noise squelch out, but it just didn't work well enough. So it's alright doing these modifications. The idea of the modification surely is to render an improvement. But when it makes a set such that it isn't going to work properly over a scratchy corner, I would have thought that preset I was looking at on the noise squelch board was the kind of preset gain level, but no, didn't do anything, did it? Right, switch it on. Yep, absolutely lovely. Put it on the aerial. So as I keep saying, it's an Antron 99 type of aerial, but there are other makes. Could be a Solarcon one. We'll unpower it. It'll have to be on crocodile clips. Let's hope. The only thing we haven't... Did we check the speaker when we first had it? I can't remember whether we did or we didn't. So we'll just do the soldering of that. If I'm a really good boy, we'll see which way around it goes. I say many times it really doesn't matter, but we'll just check. So which one of these goes to Earth? Not that one. Hang on a minute. One of them does. Let's try it to one of the cans instead. Not that one. It's that one. So negatives are one on the left. Good. So I'll just put, I'm not putting the back screws in yet. I'll wait till we've done scratchy corner test. Just in case it's got to come apart again. Okay, well if it only wants one in that side, that's all it's going to get for now. Right, aerial in. Well, Nana, Roger. Now notice how the meter bangs across, even though we set it correctly when it was on the test equipment. This is what I'm always saying. The radio's still doing 4 watts. That means nothing.
On FM, but yeah, nice to meet you, Paul. And yeah, well, so microphone back to you. India Hotel 55, Charlie, Quebec.
Sounds somebody foreign. Hope he's on 4 watts. Right, we'll leave it like that. Ready for a scratchy corner test for Mr. T. Hope that didn't bang too much as the ESR meter fell on top of one of the 4 microphones. Thanks for watching. Uniden 100 resurrected from an illegal piece of scrap into a beautifully working set.